चले बस स्टार्ट करते हैं ये कौन सा दिस वन इज पेपर 2-3 ठीक है समर 18 ठीक है सो दिस वन पेपर 2 पे से तो द फर्स्ट क्वेश्चन कोई मुझे टेल मी somebody should tell me कि what's draw a diagram to show the shape क्या shape है SO3 की और यहाँ पे बताया हुआ है the oxygen atoms they form a double bond so what is the shape of SO3 क्या होगी anyone Vidisha what's the shape of SO3
Sir, octahedral.
क्यों octahedral क्यों होगी कितने bonds है how many bonds do you have in SO3 उसने कहा है it's forming double bonds right the sulfur has 6 electrons तो अगर वो if it forms 3 double bonds अच्छा if it forms 3 double bonds there won't be any lone pairs lone pairs कोई नहीं है क्योंकि sulfur had 6 electrons all 6 got used up so there are no electrons ठीक है so just 3 pairs of bonds 3 bonding pairs that's trigonal so that's going to be trigonal planar fan shaped 120 degrees the angle अगला वाला Cl2O what's the shape of Cl2O यहाँ पे I'm pretty sure Cl is making single bonds with oxygen इसकी क्या होगी how many bonding pairs and how many lone pairs do you have Riyan कोई idea इसका क्या anyone ठीक है Humad it's bent and V-shaped how many lone pairs and how many bonding pairs would it have अच्छा oxygen Cl makes single bonds right so it's going to make single bonds and oxygen is in group 6 group 6 का मतलब है it's got 6 valence electrons that means only 2 electrons are used in bonding so out of 6 4 are still left so 4 electrons are left and since you have 4 electrons left the shape would have been tetrahedral but since on two sides there's no atom attached so it's just going to be counted as bent okay that's it so aapne na you're not going to draw the other side because there's nothing attached on that side so it's 2 bond pairs the angle should have been 109.5 but because the lone pairs have or exert a greater repulsion it's going to be bent or non-linear and the angle will be 104.5 ये मैं go through कर देता हूँ all the shapes ठीक है just very quickly कहाँ पे एक सेकंड देना ठीक है shapes कहाँ पे shapes ये ठीक है all of the shapes remember how to figure out how many lone pairs it's got ठीक है basic shapes ये it's either linear two pairs 3 pairs that's trigonal planar 4 pairs that's going to be tetrahedral 5 pairs that's going to be bipyramidal trigonal bipyramidal ठीक है और 6 के साथ it's going to be octahedral ठीक है these are your basic shapes but then फिर वहां पे ना there's lone pairs ठीक है for example in our case it's we were dealing with this one we were dealing with this situation that we had 4 pairs but on two sides we had lone pairs and on two sides we had bond pairs so the shape of the molecule would be I mean it's going to be derived from a tetrahedral shape but it's going to be bent and it's going to be V-shaped or non-linear or bent 104.5 lone pair की repulsion ज़्यादा होती है so tetrahedral 1 lone pair so that's going to be pyramidal 2 lone pairs that's going to be bent anyways so let's go back to the question explain why the melting point of MgO is much higher than Na2O first thing is this ionic I mean, it's obviously ionic. Ionic है, ठीक है, तो क्या रीजन है? Why is it? क्यों है उसका melting point higher?
सर चार्ज डेंसिटी ज्यादा है सर एनजीओ की।
ठीक है, exactly, क्यों ionic के अंदर ना this one has अच्छा उसने पहले बताया था why the melting point, so this one is ionic. Both of them are ionic, ठीक है, they're giant ionic lattices. Or Mg plus 2 ion has a greater charge density compared to Na plus 1. So Na plus 1 is not going to attract the O minus 2 that strongly. Mg plus 2 will attract the O minus 2 very strongly. Okay? Obviously, it's plus 2. Plus 2 is going to exert a greater force of attraction. So it's going to have greater charge density. So it's going to form stronger ionic bonds. So there would be stronger ionic bonds in NGO. अब वो अगले part में he's saying that why is the melting point of SiO2 greater than SO3? उसकी क्या? What's the reasoning for that?
फिर SiO2 macromolecular और SO3 फिर वो simple molecular।
ठीक है, so it's macromolecular. उसके आगे भी थोड़ा सा explain करोगे कि it's macromolecular, it's got strong covalent bonds. So strong covalent bonds or a large network of strong covalent bonds need to be broken. This is simple molecular. Simple molecular, what bonds are broken? Yeah, what force is broken?
The weak intermolecular forces.
ठीक है, तो weak, only weak intermolecular forces. So that's why less energy needed for this, which is why it's going to have a lower melting point. अच्छा, अगला part explain. अच्छा, अगला part है कि one second. Now he says SO3 is produced by the reaction between SO2 and O2 in the contact process. A dynamic equilibrium is established. ठीक है? So explain why increasing the total pressure at constant temperature increases the rate of production and increases the yield. अच्छा, पहले तो increasing pressure, why would it increase the rate? क्या लिखोगे यहाँ पे?
So more number of effective collisions are occurring.
हाँ, ठीक है, more number of
The effective collisions per unit time.
हाँ, ठीक है, लेकिन why does that happen?
तो क्योंकि जो reactant की concentration है per unit मतलब से volume वो increase कर रही है।
अच्छा, so basically at higher pressure आपने explain करा कि volume decreases, right? So at higher pressure, volume decreases and particles are closer to each other. So your particles are and if your particles are closer to each other, you're going to have more frequent frequent में वो आ जाएगा per unit time आ जाएगा. Obviously frequency is that more frequent collisions. अच्छा, yield में how does that increase yield? क्या होता है when you increase pressure? What happens at higher pressure?
So low gas mode side favor हो रही है।
ठीक है, तो less gas mode side. Which is the product side. So forward, more products are going to be formed. As I explain why the gradients of SO2 and O2 they decrease with time.
लेकिन reactant की concentration कम होती जा रही है।
Well, why does the gradient decrease? The reaction is slowing down, right? हाँ, वही the concentration decreases. They get used up. Okay, concentration. The शुरू में ना the decrease is very steep, but then it slows down. Okay, so concentration of SnO2 decreases, which decreases the rate of the reaction. The gradient is the rate. So why do they become constant after a certain time?
So equilibrium achieve हो गया.
Okay, equilibrium is reached, or once equilibrium is reached, what happens? The rate of forward or backwards, whenever that becomes equal. So then the concentration becomes constant because nothing is getting used up. Suggest why the initial gradient of SO2 line is steeper than that of O2. Okay, क्यों steeper थी SO2? Why was SO2 getting used up at a faster rate?
So more particles per unit volume.
नहीं, equation से link करो ना कि every time when one O2 gets used up, so how many SO2s according to the equation are going to get used up? That's going to be double the amount. ठीक है? Clear है? तो SO2 की जो amount होगी, that's going to be double the amount of O2. Is that clear?
Yes, sir.
So words may explain kar do. Okay, it's in the equation. If one O2 gets used up, two SO2 molecules are going to get used up. So the amount of SO2 or the rate of decrease of SO2 is twice the rate of decrease of O2. Okay, double decrease hoga. So next one, you've got a question about Kc, and he's asking for he's asking for the Kc, by the way. So this is a question about Kc. Pehla step, that's you have to write the expression. So what is the expression for Kc over here? What's the expression?
So SO3 का square over O2 plus O2 into SO2 square.
Okay. Acha, remember one thing. Okay, always remember that if it's SO3, acha, a lot of people make this mistake. Okay, they don't see this. If it's Kc, then you have to use square brackets. Okay, it's going to be SO3 squared divided by SO2 squared, product over reactants, right? Their concentrations. यहाँ पे लेकिन make sure you read this properly. If you're dealing with Kp, so here it's going to be the partial pressure of SO3, that's going to be squared divided by the partial pressure of SO2 squared and the partial pressure of O2. It's the same expression, but obviously it's going to be written differently. So बहुत सारे लोग ना they just write this expression. They don't even carefully read whether they're looking for Kc or Kp. As I calculate the amount in moles of SO2 and O2 in the equilibrium mixture, the first thing, let me rewrite the equation. So the equation that we have is 2SO2 and table bana lo 2SO2 plus O2 in equilibrium with 2SO3. The initial moles that you have is you've got 2 moles of SO2 and you've got 2 moles of O2 and you've got that's it. That they were sealed in a container. So SO3 ka hai nahi. There's no moles of SO3, so there's nothing. SO3 is not there. The resulting equilibrium mixture, once equilibrium is reached, contains 1.98 moles of SO3. So once equilibrium got reached, you had 1.98 moles. So that indicates either calculate what are the moles of the rest of O2 and SO2?
Sir, O2 पे 0.999 और 1.98 for reaction.
0 point?
0.99.
जो रह गए पीछे या जो रिएक्ट में?
ये जो react में.
ठीक है. अच्छा, basically 1.98 means के you started off at 0 and you have 1.98. That means 1.98 got produced, right? And to produce 1.98 2:1, तो यहाँ पे कितना 0.99 must have reacted, right? ठीक है, 2:1 है, 1.98 got produced, 0.99 reacted. So that means out of the 2 moles, 0.99 are gone. तो पीछे कितने बन गए? That's what is left?
So 1.01.
अच्छा 1.01 moles. और फिर इसके कितने रिएक्ट हुए होंगे SO2?
7.98.
ठीक है, क्योंकि it's 2:2, so that means if 1.98 getting produced, 1.98 must have reacted. So this is 1.98 निकाल दो, तो what's left?
So 0.02.
0.02. अच्छा, so you now have your equilibrium moles. लेकिन ये याद रखना, equilibrium moles, these are your moles. आपका जो वो है ना expression that uses concentration. So he gave us a 40 dm cube container. So either to he's asking for the moles of SO2 and O2. So I'll just write that it's 0.02. And this one is 1.01. But remember this, okay, the expression always uses concentration. It does not depend on moles. It's using concentration. So the volume is given 40 dm cube. So use your expression, calculate the value of Kc. So we're going to use the expression, plug in the values, but remember concentration is used. So it's going to be SO3 concentration squared. That's going to be 1.98 divided by 40 mole per dm cube, right? So 1.98 moles divided by 40 dm cube squared. That's your product, and divide by your reactant, which is 0.02 in 40 dm cube, and that's also going to be squared. Okay, O2, that's 1.01 divided by 40, and that's power 1. ठीक है, ये भी कभी ना भूलना कि always remember कि it's not moles that are used in the expression, it's concentration. So moles over volume. ठीक है, तो आंसर बताओ क्या है?
So 3.88 times 10 power 5.
अच्छा, 10 to the power 5. And what are the units of Kc? This one, concentration squared divided by concentration squared divided by concentration. तो क्या हो गया? मोल per dm cube squared, mole per dm cube squared, mole per dm cube. So it's going to come out to be x minus 1. Okay, this one is going to come out to be x minus 1. So it's basically mole per dm cube minus 1. Yani mole minus 1, and dm would be. ये 40 से?
जी सर.
मोल्स तक क्लियर है? मोल्स तक?
जी सर, ओके.
हाँ, तो इसमें बस याद रखो, इंपॉर्टेंट है कि ये जो एक्सप्रेशन है that uses concentration. What is concentration? Concentration is moles over volume. और यहाँ पे ना he gave us के यहाँ पे he gave us that the volume of the container was 40 dm cube. Is that clear?
जी सर.
तो हर दफा ना आपके पास when you have moles तो उसको divide by 40 करना है, ठीक है, ताकि you get concentration. एक scenario में ना you don't have to divide by, you can directly use moles, and that scenario is कि if the number of terms in the numerator and denominator are the same. यानी वो तब होता है when you have equal, when equation के moles जो है ना यहाँ पे on the left side there are 3, on the right side there are 2. So obviously the numerator and denominator terms are different. लेकिन अगर वो same हो ना, the 40 will get cancelled out. अगर वो equal होते ना, like if let's assume कि ये वाला part ना होता, so it was kind of pointless to divide by 40 because that part would automatically get cancelled out. So सिर्फ उस situation में ना, when the numerator terms and the denominator terms are the same, or you have equal number of moles in the equation on the right and left side, so that means the Kc expression is not going to have any units. and there's no point in dividing by volume because it's going to get cancelled out anyways. ये बात भी clear है?
जी सर.
अच्छा, structural isomer क्या होता है? What's the definition?
The same molecular formula but different structure formula.
ठीक है, same molecule. अगला क्या बता दो? Molecules having same molecule. हाँ?
The same structure, same molecular but different arrangement of atoms.
ठीक है, इसको मतलब अच्छा same molecular formula, different structure. Molecules having same. यहाँ पे क्या होगा? It's the same molecular as well as structural. Everything would be the same, except the three-dimensional geometry is different. A different arrangement in space. So the three-dimensional geometry of the molecule is going to be different. अब अगला part है कि give two reasons why pent-1-ene does not show stereoisomerism. Two reasons. Tell me two reasons why a molecule does show stereoisomers.
फिर एक तो अगर उसके में सिर्फ कार्बन कार्बन डबल बॉन्ड किसी एक के ऊपर भी है दो डिफरेंट ग्रुप्स हो और दूसरे में ऑप्टिकल सेंटर्स हो.
ठीक है, one is कि carbon in serial bond O over here is bonded to two H atoms or same groups. So it can't show cistrons because if the double bond is bonded to two H's, then obviously switching the sides will have absolutely no effect on the arrangement. As a reason number two, chiral optical isomers, no chiral carbon. And what's a chiral carbon? A carbon atom bonded to four different groups. As the next part. Monomer is drawn. He's asking you, this is a polymer. He's asking you to draw the monomer. All you have to do is just get rid of these continuation bonds and put the double bond back in the middle. So say I draw a displayed formula. What do you mean by a displayed formula? क्या show करना होता है इसमें?
All bonds.
तमाम बॉन्ड.
ठीक है, एक bond show करना है. ठीक है, so you have to show the H. You have to show the CH3s as well. नीचे क्या, that's CH2 and CH3, so that's C with two H's. He's also asking for the, I think, name of the monomer as well. So what's the name of this molecule? क्या है इसका नेम क्या?
फिर 2-methyl प्रोपाइल हो प्रोपेन हो जाएगा. ब्यूटेन.
नहीं.
So
What is-
2-methyl butanene.
हाँ ठीक है, 2-methyl butanene है. ठीक है, क्योंकि this is the longest chain. It's it's 4 carbon atoms, right? So that is butanene. And there's a methyl group on the second one. Okay, this is 1, 2, 3, 4. So this is 2-methyl. As a 2-methyl butanene. A different isomer of this does not show cistrons. Okay, a different structural isomer of pent-1-ene shows a geometrical isomerism. Draw the structure of one of the two geometrical isomers with the formula C5H10. Give the full name of this isomer. So he's saying that draw one of the geometric isomers. Okay, so it should. So I want to make an isomer that shows cistrons. So for cistrons, this side, both sides will be should be different. Okay, so I can add an H over here, and CH3 on the other side. ठीक है, कितने carbons रह गए? I've got 5 carbons in total. So this is 3 carbon atoms. So I need to fit in 2 more carbon atoms. So this side should be different as well. So I can put 2 carbon atoms over here. So that will also show cis trans. ठीक है, और इसका क्या नाम है? What's the name of this molecule? ये तो clear है, it's cis trans, right?
ये पेंटुइन हो जाएगा।
Sir, cis-pentuene.
हाँ, cis pentuine अगर ज़्यादा exact हो, so that's cis pent 2ene. Next one. As a group 17, ठीक है, remember inorganic, ठीक है, उसको prepare करना paper 2 के लिए, ठीक है, you can pick questions. Now this is about group 17. The halogens show trends in both their chemical and physical properties. The elements in the compounds have a wide variety. So group 17 cool, let's say, ठीक है, what's group 17? Inorganic. Yeah. As a group 17. State the trend in the volatility of group 17 elements down the group. क्या है trend? And explain the trend.
सर इंक्रीज कर रही है।
Increase कर रही है?
Sir, decrease करेगी.
वो evaporate तो नहीं हो रहा, so it's going to decrease. But fluorine is a gas. Cl2 gas, Pr2 liquid. Okay, why? What's the reason for this?
So number of electrons increase करने इस वजह से, और bond strong है.
ठीक है, so नहीं, bonds नहीं. Number of electrons की तो बात ठीक है. उससे क्या हो रहा है? कौन सी इंटरमॉर्गुलर फोर्स है ये? इसमें क्या है? Cl2 what is the
Intermorphic forces.
हाँ ठीक है, तो वो क्यों इंक्रीज कर रही है डाउन द ग्रुप?
फिर कांटेक्ट पॉइंट्स इंक्रीज कर रहे हैं, बड़ा मॉलिक्यूल।
हाँ लेकिन हाँ ठीक है, but not contact points. Either contact points are not increasing.
क्योंकि से electrons भी increase करने इस वजह से.
हाँ.
और
So down the group, your bigger molecules, more electrons, right? Shian, वो जो contact points वाली बात है ना, that's about surface area. If you have a carbon chain which is straight chain carbon chain है, या फिर एक branched carbon chain है, तो straight chain will have more contact points, ठीक है?
ठीक है।
अच्छा, लेकिन इसमें simple है. Down the group, you have more electrons. Bigger molecule, you have more electrons. So you have more electrons, which is why you're going to have more van der Waals forces. बल्कि और van der Waals के साथ ना हमेशा always just as a habit, right? Instantaneous dipole induced dipoles. अच्छा, now this one. A displacement reaction. ये Oliv's करके more reactive displaces is the Cl2 is the more reactive one. Top one is the more reactive one. So Cl2 will displace I2. So it's going to become NaCl plus NaCl plus I2 form हो जाएगा. So that's it. And you just need to balance this. So there's going to be 2 Cls and 2 NaIs. Next part is silver nitrate solution. Silver nitrate, the test, it's a test for halides. So explain karo ke what's the color of the precipitate if you have iodide or if you have chloride. Iodide mein what's the color?
सर पेल येलो आ जाएगा।
नहीं, yellow होता है. वो जो बीच वाला होता है ना, that's Br-1, that's pale cream precipitate. The other one is white precipitate.
सर Br में क्रीम प्रेसिपिटेट नहीं होता?
हाँ क्रीम होता है ना, या ऑफ वाइट. Iodide वाला ना, that's like proper yellow. As a name of precipitate, what is the name of formula of the precipitate?
silver iodide.
ठीक है, मतलब इधर नेम का है तो सिल्वर आयोडाइड लिखोगे, not the formula, but let's write the formula. AgCl. ठीक है, write the name with it. Which of the precipitate is soluble in ammonia?
सर क्लोरीन, सिल्वर, सर क्लोरीन.
Okay, so this one will dissolve and this one will not dissolve. Okay, it's not soluble. So effect, or say, he's not asking for the equation, but do you know what the equation for the precipitate dissolving in ammonia is? AgCl जो solid है ना, that dissolves in ammonia. So what happens is that the silver ions, they form a complex which is also known as Tollens reagent. Tollens reagent का ये formula, ठीक है, that's organic का part है. But this is known as Tollens, and the Cl minus. So basically, the AgCl will ionize. It will form this ion and this one. So it's important to remember this equation as well. Complexes are not in your course. They can. You have to remember this one. Okay, silver ions will dissolve in ammonia, and the ammonia molecules will get, because of the lone pairs, will get attracted to the positive silver ions, and they will surround it. So that's how AgCl dissolves. So anyways, he's not asking for the equation, but remember this equation. Okay, what happens when the precipitate dissolves in ammonia? फिर write an ionic equation including state symbols to show the reaction. तो ionic equation क्या है? इसका जो silver ion है और इसका जो I-1 है, they basically combine and they form AgI, which is solid. And these two are aqueous. So that's your ionic equation, okay? As the next part. Now this part is कि wait correct. अच्छा, I-1 reacts with ये sulfuric acid के साथ reaction, ठीक है? So let's go through the reaction. What's going to happen? What happens down the group? ठीक है, this is what happens down the group. Okay, when you have I-1, Cl-1 or Br-1, तो उसके अंदर remember this, that the halides become good reducing agents down the group. F-1 and Cl-1, they don't like to lose electrons because they're very small ions. They tightly hold on to their electrons. Like in Br-1 and I-1, they're very good reducing agents because they're bigger ions, they're more shielded, so they lose electrons very, very easily. Okay, so the bottom two, they're very good reducing agents. So what happens with sulfuric acid is, sulfuric acid with NaCl will only have a displacement reaction. Or isko idhar वैसे add करें, it's an acid-based reaction. I mean, the type of reaction is an acid-based reaction. So what happens is that Cl-1 will combine with H+1 and form HCl gas, TK, and solution will have this thing. But down the group, when you have Br-1 and I-1, you get displacement, but at the same time, you also get a redox reaction. Because Br-1 and I-1, they really like to lose electrons. So the Br-1, they start losing electrons, they start forming bromine. I-1 also likes to lose electrons, starts forming iodine, and you get a lot of redox products. And the sulfur gets reduced. So ये basically यहाँ पे लिखना है. This question is saying that NaI reacts with sulfuric acid to form purple iodine and H2S. However, NaCl reacts with sulfuric acid and the only gas produced is HCl. So you have to explain the difference in the reaction. Your answer should refer to the role of sulfuric acid in each reaction. So the first one, उसका लिखता है कि पहले लिख दो कि Cl-1 is not a good reducing agent. And explain the difference. Your answer should refer to, so he's not really asking for equations. So Cl-1 is not a good reducing agent. So an acid-base reaction happens. Where what happens that the H2SO4 acts as an acid. So role pucha tha, acts as acid. And you can write the equation that what does an acid do? It produces H+1 ions. And what does a base do? It accepts H+1 ions. So Cl-1 will accept the H+1 ions and it will form HCl gas. And solution में NaHSO4 would be left. I mean, HSO4 minus 1, Na+1, that's going to be left in the solution. So that's the first part. Or down the group, what happens? I-1 really likes to lose electrons. I-1 is it's a very good reducing agent. So it's a good reducing agent, and because of that, the sulfuric acid behaves as an oxidizing agent. So आपका जो sulfuric acid है, it's behaving so it's behaving as an oxidizing agent, and you can write the equation. ठीक है, बस यही होगा. लेकिन ये चीज याद रखना, this question comes very frequently. What happens down the group? As a chlorine is used in water. ये वाला clear है? ये वाला part clear है?
It's not repeat.
क्या चीज?
Sir, could you repeat this one?
देखो ये था ना inorganic के अंदर, if you check your notes, ये जो bottom ones है ना, Br-1, I-1, they're bigger ions and they lose electrons very easily. ठीक है? Do you get the idea? कि they want to lose electrons. ये जो top ones are the smaller ions, they don't like to lose electrons. तो जो bottom two है ना, they're very good reducing agents. ठीक है? Anyone who loses electrons acts as a reducing agent. तो यहाँ पे क्या होता है कि NaCl के साथ you don't have a redox reaction. The only thing you have is that the Cl-1 basically attaches to an H+1 from the acid and ends up forming HCl gas. So you have an acid-based reaction. No one is losing electrons, no one is gaining electrons. किसी की भी oxidation state जो है ना, that did not change. Lekin down the group Br-1, I-1, they really like to lose electrons. So what happens is that when NaI reacts with sulfuric acid, you do get displacement, but the I-1 likes to lose electrons, so it starts getting oxidized, and the sulfur starts getting reduced to either sulfur dioxide or sulfur or H2S. तो ये बात समझ आइए कि इनका हमेशा redox reaction होगा. Is that part clear? So यहाँ पे ना sulfuric acid is behaving as an oxidizing agent because anything that reacts with the reducing agent is basically an oxidizing agent. और यहाँ पे sulfuric acid is behaving as an acid क्योंकि वो H+1 दे रहा है उसको. Explain the meaning of the term oxidizing agent in terms of electron transfer. So gains electrons or loses electrons? क्या होता है? What does an oxidizing agent do?
Gains electrons.
ठीक है, so it gains electrons and oxidizes the other substance. खुद reduce होगा. Suggest an equation for the reaction of chlorine with water. What are the two products when chlorine reacts with water?
HClO.
और इसके अलावा chloric 1 acid plus what?
HCl.
H2.
नहीं plus HCl. वो दो acids बनाता है. I said write an equation for the reaction of chlorine with hot and NaOH. TK. This one also comes very frequently. So what happens with hot NaOH? There are two reactions. TK. दोनों के अंदर bleach is formed. Where's the reaction? NaClO3 is formed. This one. Okay, hot NaOH के साथ it's going to form NaCl, NaClO3 and H2O. TK. And you must know the balancing of this equation. TK. It's going to be very hard to balance this equation during the exam. क्योंकि उसके लिए ना पूरी working करनी पड़ती है. And I'm going to tell you how this equation is going to get balanced. NaOH क्या बन रहा है? NaCl plus NaClO3 plus H2O. अच्छा, so balancing this equation, any redox equation has to be balanced in a different way. So how would you balance this equation? अगर तो याद नहीं है, ठीक है, what you're going to do is you'll figure out the oxidation states first. Cl is 0 initially. Over here, Cl is -1. यहाँ पे क्या है Cl? What is the oxidation state of Cl in NaClO3? O -2 होता है, Na +1 होता है. So what is Cl over here?
+5, sir.
ठीक है, so it is +5. But Na is +1. Cl is unknown, so that's x. And O is -2, O3 is, so that's -2 times 3, and everything should add up to be equal to 0. So if you solve this, it's going to come out to be +5. Achha, so what is the name of the reaction where an element gets oxidized and reduced? What would you call it? Cl is getting disproportionation. Okay, so Cl is getting reduced. Gaining electrons, Cl is also getting oxidized, losing electrons. It's forming a positive as well as a negative ion. So it's getting reduced, it's getting oxidized both at the same time. How many electrons is it gaining? It gains 1 electron, right? Well, -1, so it gains 1 electron. But on the other side, it's becoming +5. So that means it loses how many electrons? Loses 5 electrons. So redox balancing mein kya hota hai ki what you need to do is you need to balance the number of electrons that are lost and gained. So I just need to multiply this by 5. Agar 5 honge na to electrons gained and lost would be equal. So that means Cl -1 kitne hone chahiye? I should have 5 of them. I should have 5 Cl -1s. So how many total Cls should I have initially? I got 1 Cl +5 and 5 Cl -1, so that's 6 Cl. So there should be, both of them are starting at the same starting point. So that's going to be 6 Cls over here. Is this clear? Ki balancing clear hai? Ki in a redox reaction,
जी sir.
always balance the number of electrons gained and lost. Or दूसरा ये कि so always balance the number of electrons gained and lost, and balance the other stuff. Na kitne ho gaya? That's 5 Na, 1 Na, that's 6 NaOH. Or water kitne ho jayenge? That's going to be 3 water molecules. That's it. So since it was a 2-mark question, it would be a lot better if you just remember how this equation is balanced. Actually, you would have to. I mean, you could. Ye wali nahi, just ye wali. Let's say this one, HI with H2SO4, I2 H2S. Like in the exam, it would be very hard to actually balance this equation. If they ever ask you to write this equation, तो इसमें भी वही करना पड़ेगा. You either remember the balancing, which would be extremely hard. I mean, it would be extremely hard to actually memorize all these equations. ठीक है. तो लेकिन इसका भी try कर लेते हैं. Let's say you've forgotten how this equation got balanced. So it's HI and H2SO4. Let's try and balance this one as well. Okay, HI plus H2SO4 क्या बन रहा था? That's forming I2 plus H2S plus water. ठीक है, that's the equation. So how do you balance this in the exam? Okay, I is -1 over here. Sulfur is, okay, what is the oxidation state of sulfur over here?
+6 +6 sir.
ठीक है, +6 है. और फिर आगे जाके I2 is 0. What is sulfur in H2S?
Sir -2.
ठीक है, -2 है. So I remember H is +1 everywhere. H is always +1. O is -2. So I have not written it, but it's obvious. ठीक है, O is -2. So who's getting reduced? Who's getting oxidized? ये -1 से किस पे जा रहा है? 0. So that means that -1 से 0 lost electrons, right? Lost 1 electron. वो जा रहा है +6 से -2. So that means it gained how many electrons? Gained 8. 8 electrons हुए ना? Clear है? तो बराबर करने हैं. You have to make them equal. So I need to multiply this by what? I need to multiply this by 8 से multiply करना है, right? So I should have 8 I -1s. And I should have 8 iodines that are 0. So यहाँ पे I would just multiply it by 4. ठीक है? So now the equations electrons gained and lost are equal. Is this clear?
Yes, sir.
Yes.
Yes.
और बस एक चीज अब रह गई है जो बैलेंस करनी है. That's water molecule over here. So you just have to. So how many H's do you have? You've got 2 H's. 8. That's 10 H's. So there's 2 H's. So 4 H2O's. ठीक है? So everything would be balanced now. मतलब जो चीज रह गई है ना उसको फिर नॉर्मल तरीके से बैलेंस कर लो. But always remember redox balancing, it's always you make the electrons gain and loss equal first, and then you balance the rest of the equation. So in सारे redox reactions में in inorganic chemistry, you're going to get stuck with the balancing part. If you try to, it's impossible to balance it in the normal way. मतलब इसको आप जितना मर्जी try करो ना, it's never going to get balanced if you try the normal way. So okay, organic question. This is a halogen alkane, ठीक है? So he's saying कि name A, that's the first thing. Some reactions of A. Achha, what is the name of this thing?
Sir, bromobutane.
लेकिन क्या bromobutane? It is butane, ठीक है?
Sir, 2-bromobutane.
2-bromobutane.
हाँ ठीक है, 2-bromo. ठीक है, bromine is on the second one. Name the class of compounds to which B belongs. B कहाँ पे? B is this one. अच्छा तो what type of alcohol is this? Primary, secondary, tertiary, कौन सा?
Sir, secondary.
ठीक है, carbon chain इस पे बीच वाले पे it's an OH, then carbon another, carbon 3 H's, 2 H's, 1 H, 3 H's. Now this OH is a secondary alcohol. Secondary alcohols will get oxidized to what?
Sir, ketone.
ठीक है, so it's going to get oxidized to, secondary alcohols always form ketones, right? So it's going to be a ketone. यानी वो ketone भी मैं draw कर लेता हूँ, it's going to be, वो जहाँ पे OH था ना, you're going to have a double bond over that side. 2 H's, 3 H's. So it's going to be a ketone. So the class of compound is going to be ketone, or you can / carbonyl कर दो. ठीक है. Now there are 3 structural isomers of A. इसके. Draw those 3 isomers. तो क्या होगा? 3 isomers of bromobutane. Where should I put the Br now in an isomer?
By the way, sir,
Hmm.
जब वो आइसोमर्स का बोलते हैं तो जो पहला ड्रॉ हुआ होता है वो तो नहीं वापस ड्रॉ कर सकते ना?
नहीं, इधर जिस तरह से
जो
बोल, नहीं जिस तरह से इधर बोलना है, 3 isomers of A draw करने हैं. So you have to
Mhm.
draw 3 isomers of A, यानी A को exclude कर दिया,
Okay.
apart from A.
Okay.
तो अब बताओ पहला क्या होगा? What's the first?
OH at the end.
नहीं, bromine है.
So okay, bromine at the end.
हाँ, A is this thing. So bromine on the first one, ठीक है? So that's यहाँ पे H, write down the H. अच्छा, what's this?
Second पे bromine at the second.
नहीं, वो तो हो गया, वो तो ये है. Bromine at the second is already there.
CH3 change करना है, उसको chain बना ले.
ठीक है, मतलब instead of 4 carbons क्या करना है कि you just make it 3 carbons and add a Br over here. ठीक है, ये H, add the H's. Okay, finally you have another version of this, a positional isomer के Br, put the Br in the middle one. ठीक है, remember Br on the sides, that's all of them would be the same thing. ठीक है, so that's your 3 isomers. Now reaction 1 occurs by 2 different mechanisms at the same time. The mechanisms are referred to as SN1 state. What is the letter S? So SN1, what does S stand for?
Substitution
और N क्या होता है?
and nucleophilic.
ठीक है, substitution, nucleophilic. Now this one. You see, complete the SN1 mechanism for reaction number 1. तो क्या होता था? What's the, for reaction number 1, OH वाला, 1 second. He's talking about this reaction with the NOH. So SN1 mechanism में क्या होता था? What's the SN1 mechanism? और SN2 में क्या होता था?
SN2 was 1-step reaction and SN1 was 2-step reaction.
ठीक है. तो उसमें कहाँ पे चार्ट ही हो रहा? तो आपके SN1 में कार्बोकैटायन किस में बनता था? ये मैं दिखा देता हूँ. अच्छा, these are your two reaction mechanisms for halogenoalkanes, ठीक है? Now, every halogenoalkane, the carbon which is the alpha carbon that is bonded to the halogen, it has a polarity, ठीक है? It's partial positive. And the Cl is partial negative, ठीक है? It's a polar bond. तो SN2 में होता था कि the nucleophile, it's whether it's OH -1 or NH3 or CN -1, they will directly attack the carbon and the electrons in the Cl are going to get repelled. तो वो एक ही step में the OH is bonding and the Cl is getting knocked out. So the OH is going to take the place of the Cl. अब SN1 में होता था, that was for tertiary halogenoalkanes, that the Cl would break off first and a carbocation would get formed because the Cl is gone, and then the OH -1 would come and take its place. ठीक है? So it would form an alcohol. So we have to draw this one, the SN1 mechanism. In this case, तो इसमें क्या होगा? The Br is going to get knocked out first. Slight negative. So what you'll have is a formation of a carbocation. Or here the nucleophile is going to come in with its lone pair, and it will form an alcohol. So SN1 mechanism for reaction 1 is repeated using a chloro. Now instead of bromoalkane, he's using a chloroalkane and an iodoalkane. So State explain the rate of these two. Which one would have the faster nucleophilic reaction? Chloroalkane, iodoalkane, or bromoalkane? किसका fastest होगा?
Sir, iodo?
और क्यों होगा?
क्योंकि इसके bonds weak हैं.
हाँ ठीक है वही. So Ci bond is very weak. Bigger atoms always form weak bonds. So because the first step involved the breaking of the halogen bond. So in the case of iodoalkane, it will happen very quickly. और slowest कौन सा होगा फिर इसके vice versa? iodoalkane की जगह ना पूरा नाम लिख देना. Slowest होगा chloroalkane, right? That will be the slowest. Why? Because the CCl bond is the CCl bond is very weak. एक सेकंड देना.
सर या वापस समझा सकते हैं?
Halogenoalkanes में क्या था? Reaction में क्या करना था? The first thing was that you had to break the CBr bond, right?
Yes.
तो अगर वो bond weak होगा तो क्या होगा? The reaction will be fast, right? अगर तो bond strong होगा, it's not going to happen. The bond is not going to break. So bond कौन सा strong होता है? The smallest atom makes the strongest bond. The biggest atom makes the weakest bond. तो iodine वाला जो bond है ना, if it's इसकी जगह, if bromine की जगह you had iodine, right? तो iodine का जो bond होता है, that would be very weak. So that would mean it would have the fastest reaction, ठीक है? अगला part, reaction 2 uses the same reagent as reaction 1 but under different conditions. ये NOH का याद रखना कि NOH aqueous होगा ना. Like for halogenoalkanes, always remember NOH, if it's aqueous, so it will form alcohol. You'll have substitution, and if NOH is ethanolic, it will turn into an alkene. ठीक है? तो same reagent, NOH aqueous turns into alcohol, substitution. NOH ethanolic, you get elimination. It turns into an alkene. So use this as the same reagent as reaction 1, but under different conditions. State 2 differences in the conditions needed to ensure that the reaction 2 is more likely to take place than reaction 1. Reaction 2 कौन सा? That's the one that produces the alkene. तो वो कह रहा है कि दो changes बताओ. तो one is it's going to be ethanolic. Solvent is going to be ethanolic. और concentrated होना चाहिए. Two is more likely to take place than reaction 1. बस ये solvent इधर clearly लिखते हैं ना, solvent should be ethanolic. Is this clear?
Yes, sir. How about the heating part, sir?
Different. तो heating तो उसमें भी है. इसका मैं check कर लेता हूँ. I mean, you can add heating, you can write that, but the reason I didn't write it because you need heating in the other one as well. खदीजा क्या क्वेश्चन है? एक सेकंड पहले वो मैं आंसर कर लूं. हाँ ये गलत लिखा हुआ है. वीक नहीं है, इट्स वो वीक तो ऊपर वाला था. स्लो रिएक्शन इसलिए होगा क्योंकि द बॉन्ड इज वेरी स्ट्रॉन्ग. ठीक है. अच्छा मेरे को लास्ट क्वेश्चन था व्हिच इज हाँ हीट का उसने लिखा हुआ है instead of aqueous ethanolic, and he said that it's say different तो नहीं. heat under reflux तो वो भी था just higher temperature. तो इसके अंदर मैं ऐड कर देते हैं. 1 second. कहाँ गया मेरा चार्ट? So the only difference was हाँ ठीक है, difference तो फिर almost नहीं है क्योंकि the other one required heat as well. Heat यहाँ पे I'm just going to add कि it relatively requires a higher temperature. बताया उससे फिर भी कोई नहीं है कौन सा टेम्परेचर, लेकिन ठीक है. वरना हीट वाज रिक्वायर्ड इन बोथ. वो एक हमारा गलत हुआ. चलो ठीक है. और तो कोई क्वेश्चन नहीं किसी के? पेपर खत्म हो गया.
Sir, for the previous question, the one with the CCl bonds and the CCI bonds, should I quote bond energies from the booklet as well, or there's no need for that?
No, firstly, you don't have a data booklet now. Secondly is he didn't ask for the data booklet, right?
Oh, yes, sir.
Well, if I said now it's going to be quoted next to the question, right? So if they just quote the values, then you obviously use them. I don't think he didn't mention uska agar main market scheme check karuna 1 second. So maximum 3 marks, right? So he's saying that yeah, वो और के अंदर लिखा हुआ है, or this you could quote the values, right? So there was no need for quoting the values. Is that clear? ठीक है, clear है?
Yes.
बस ठीक है. उम्मीद है फिर कल कर ले वो वाला part.
It's okay, sir. It's okay. Thank you.
चलो ठीक है. Okay then everyone take care.
सर A2 की क्लास है
9:30 है. एक सेकंड, मैंने क्या टाइम दिया? एक सेकंड. तो 15 minutes में. ठीक है.
ओके.
ओके, अल्लाह हाफिज़.